right, so today's lesson is 1-3. It's factors and multiples. Now, I do want to let you know that this video is only going to be for the greatest common factor, the GCF. It's only half of lesson 1-3, and we will continue the lesson next class, okay? So here on the warm-up, all I ask you to do is write your vocabulary, okay? So a factor are numbers that we can multiply together to get another number. So for example, we have 2 times 3, that's equal to 6, right? So 2 and 3 are factors of 6. 7 times 8 is 56. So 7 and 8 are factors of 56. Make sense? All right. Common factor. A common factor is a number that is a factor of 2 or more numbers. It's just what they have, the factors that they have in common. Okay? The greatest common factor is the biggest one of the common factors. Okay? So the greatest common factor is the greatest of all of the common factors. So here we're going to list the factors of each number. Okay? So the factors of 12, again, we're looking to see what numbers can we multiply to get 12. Okay? All right. So when we list those factors, of course, we've got 1 times 12. We've got 2 times 6. And we have 3 times 4. Okay? So for number 2, it says a group of 36 students are attending a science fair. At the fair, they are divided evenly into smaller groups. How many different groups of students can be made? So on this one, we are finding the factors of 36. So what numbers can we multiply to get 36? All right, so the factors of 36 we have are 1 times 36. We have 2 times 18. We have 3 times 12. 4 times 9, and of course 6 times 6. If you just answer the question like this, that's not the answer to the question, right? We want to know how many groups there would be, right? So we could have one group of 36, 2 groups of 18, 3 groups of 12, and so forth. So example 1 is find the GCF by using a list of factors. So GCF again stands for greatest common factor. All right, so we're going to multiply, what can we multiply to get 40? Let's start with ones, okay? Of course, 1 times 40, and then we've got 2 times 20, good. 3? No. 4? 4 times 10, very good. Let's see, 4 times 10. 5? Yep, 5 times 8. 6? Nope. 7? Nope. 8? And there we are again. Does everybody see how we know we're done? All right. So now we have 48. So 48, we've got, starting with 1 again, 1 times 48. 2 times 24, good. 3 times, very good. 16, very good. 4 times 12. 5, no. 6 times 8. And very good, and no 7s, right? All right, so these are the list of factors for 40 and 48. The ones that they have in common are the 1s, the 2s, the 4s, let's see, the 8s, and that is it, right? So those are the common factors. So out of the common factors, which one's the biggest? That is 8. So 8 is the greatest common factor. The GCF is equal to 8. So now you need to remember for the next example that we're going to do, remember that the numbers we can multiply together to get another number, those are the factors. Okay? So on this example, there are 200 boys. There are 180 girls, and there are 60 teachers participating in the school field day. If the participants are divided into groups so that each group has the same number of boys, girls, and teachers, how many groups will there be? Okay, so what we are trying to find is the greatest common factor of 200, 180, and 60. So we're going to start with the ones, okay? So 1 times 200. 2 times 100. Good. 3? Nope. 4. 4 times 50. How about 5? 5 times 40. Good. How about 6? How about 7? No. How about 8? 8 times 25. 8 times 25. Good. How about 9? 10?
Yeah, 10 times 20.
10 times 20. Anything else in between 11, 12, 13, 14, 15, all the way to 20? Nope, that's it, right? That's it. All right, so 180. We've got 1 times 180. 2 times 90. 3 times, good, 3 times 60. 4? So yes, we do have a 4 times 45. How about 5? 5 times 36. 6 times 30. Very good. 9. It was 7. No 7. 8. Do you have an 8? No. No. 9. 9 times 20. Very good. And then 10 times 18. Anything between 10 and 18? Nope, that's it. And then we've got 60. So that's 1 times 60. 2 times 30. 3 times 20. 4 times 15. Very good. 5 times 12. And 6 times 10. Anything else? Nope, that's it. So, you guys, the numbers that we have in common, we've got 1s, we've got 2s, we've got 4s, 5s, we have 10s, 20s, and I think that's it, right? So here, our greatest common factor is 20. Okay, so our GCF is equal to 20. So that's how you find the greatest common factor using lists. So, ooh, what a pain in the neck that was, right? So I don't like it. There's a better way to find the greatest common factor, and that is using factor trees, prime factorization. Okay, factor trees and prime factorization. So, what is a prime factor? A prime factor, and you guys write down this vocabulary, is a number that has exactly 2 factors, 1 and itself. Okay? The prime factorization is writing a number as the product of those prime factors. Okay? Make sure you write down that vocabulary. So, 3 is a prime factor. 11 is a prime factor. Right? 17 is a prime factor. Is 8 a prime factor? No, because I can multiply 2 times 4, right? Okay, very good. So this, you guys, if you remember, this is the format of what the factor trees look like. And when you do the factor trees, that's what's going to get you your prime factorization. Okay? So example 2 says, find the GCF by using the prime factorization. We use factor trees and prime factorization to find the GCF of 120 and 300. So when we're using our factor trees, we want to break down the 120 all the way down to prime numbers. Okay? So you're going to say, what times what equals 120? You can use any of those factors. I'm going to say 12 times 10. Everybody okay with that? Okay. So 12 times 10. Okay, you can use anything that multiplies to get 120. Now, are those prime? No. So we can break it down some more, right? What can I break down 12 to? 6 times 2. How about 10? Is that prime? Nope. I can break that down to what? 5 times 2. Now, are all of those prime? No. Which one can I break down still? 6. So 6 breaks down to 2 times 3. And then you guys, please make sure you bring down everything else. Make sure you bring down everything else. So are those all prime? Yes. So this is the prime factorization of 120. Okay? Now we're going to break down 300. 300, let's start with 30 times 10. Okay? Does that give me 300? Yep. Are those prime? Nope. Can I break down 30? To what? We can do 15 times 2. I'm gonna do 6 times 5. You okay with that? Okay. So I'll do 6 times 5. And then we can break down to 10 to what? 5 times 2. Okay? Are those prime? All except for 6. So we need to break down the 6 to, very good. And then don't forget to bring down the 5, and then bring down that 5, and then bring down that 2. Are those all prime? Yeah. So that is the prime factorization for 300. You with me? You good? All right. So now we need to organize it in lists. Different kind of lists, not those other kind of lists. So for 120, we're just going to rewrite the prime factors in order. I like to write them in order. So that's 2 times 2 times 2, 2 times 2 times 2 times 3 times 5. Everybody good so far? And then we've got 300. 300, we've got, let's see, 2 times 2 times 3 times 5 times 5. Now, to find the greatest common factor, we want to see what prime factors they have in common. Okay? So we're going to circle what they have in common. So we've got some 2's here. See, and if you circle it once, you can't circle it again. Okay? We've got some more 2's here. You should be writing this in your notes. What else we have? We've got some 5's over there. We've got some 5's over there. And we've got some 3's. And these, you can't pair those up with anything, so you can't circle it. Is everybody clear? So now, to get the greatest common factor, we're going to multiply what they have in common. So we're going to multiply 2 times 2 times 3 times 5. So 2 times 2 is 4. 3 times 5 is 15. And 4 times 5 is 60. So my greatest common factor is 60. All right, so for this example, you're going to use factor trees and prime factorization to find the greatest common factor of 24 and 60. So we're going to start with 24, and we're going to break it down. So let's do 4 times 6. So 4 times 6, we can break those down. 2 times 2 for 4, and 2 times 3 for 6. For 60, we can break that down to 6 times 10. And the 6 can be broken down to 2 times 3, and the 10 can be broken down to 2 times 5. And now we organize in our list of prime factors. So we have 24, that's equal to 2 times 2 times 2 times 3. 60 is equal to 2 times 2 times 3 times 5. And now you're going to circle what they have in common. So we've got 2's in common here, 2's in common there, and 3's in common there. So to find the greatest common factor, we're going to multiply 2 times 2 times 3. So 2 times 2 is 4 times 3 is 12. So the greatest common factor of 24 and 60 is 12.